Welcome to Data Science 1, Probability, the F distribution. Things we're going to have to remember. We're going to have to remember what a cumulative distribution function is, a probability density function, the chi-square distribution, the normal distribution, and the t-distribution. Okay, so our motivation again is not motivated by an experiment. It is motivated by the following test statistic, which is from a one-way ANOVA here, the mean square treatment over the mean square error, and you can look at it and you don't really have to pay attention to anything other than the fact that it has some squares in it. Okay, this is mean square, square squared. So the one-way ANOVA test statistics is looking for differences in means across k different groups. Now, the thing to notice is the word squares, and they're both in the numerator and the denominator, and so leading us to think this might be a ratio of chi-squared distributions, and if that was the case, what would its distribution be? So suppose x is chi-squared with degrees nu 1, and y is chi-squared with degrees of freedom nu 2, and x and y are independent. Then the F distribution is given by this. So it would be F is the ratio of the chi-square divided by its degrees of freedom over another chi-square that's independent that's divided by its degrees of freedom, and this forms an F with nu 1 and nu 2 degrees of freedom. And here nu 1 is called the numerator degrees of freedom, and nu 2 is called the denominator degrees of freedom. Now, this is all well and good, but how does this stack up to the density? And when you stare at the density, you go, well, I didn't see that one coming. But that's fine. This is the density for it. We're not really going to worry about it too much because it involves beta functions and all kinds of other stuff. But this is the density, and the density has to be greater than 0 because remember, there's squareds involved. The expected value here is nu 2 over nu 2 minus 2. So nu 2 has to be greater than 2 for that to happen. And the variance is this function here. I'm not going to list it off because I'll probably twist my tongue doing it, but nu 2 has to be greater than 4 for the variance to deal with. Now, the CDF for this thing does exist, and it involves an incomplete beta function, which we're going to skip over, so we're just going to use the computer. All right, so what do the degrees of freedom do? So here's nu equals 1, nu 1 equals 1, nu 2 equals 5. So you get this picture here. Notice it's not pinned down at 0, 0. It just descends down. All right, so if nu 1 is equal to 3 and nu 2 is equal to 5, notice we have 0, 0 again, and we get this shape. It's highly right skewed. So we get a sense of what's happening there. If we add nu 1 equal to 4, you can see it shifts it over just a tiny bit. And if we have 5, it shifts it over a bit more. And now we'll start changing nu 2 and see what happens. And you can see that it's slowly shifting it over and becoming more peaked as we go along here as we increase nu 2 to 50. The other thing to notice, and this is the real important thing, is that this is getting pulled back. Okay, so I'm going to go back here. Notice this edge out here. Instead of being this far out, it's going to be under it. Okay, it's getting pulled back towards the origin. See, the blue is under it. And then we're going to have the green under it. And then we have the purple under it. So things are getting pulled back more towards the origin. So that's what these degrees of freedom do. Is it that important that you remember all of this? Probably not, but we are going to use the F distribution throughout this course, so you might as well get used to it. You want to use a computer? We all want to use a computer for this. So here, so for a value x with degrees of freedom df1 and df2, the probability of f or x is with df1 and df2 uses pf for r and f.dist for excel, and you have to add the word true on. And here the CDF for you have p probability and degrees of freedom df1 and df2, you use qf or F inverse in Excel, and these will give you the answer you're looking for, and we'll use those in a later video. All right, in summary, here's the F distribution, and it's quite large and involved formula, and here's its expected value and variance, and we're going to use a computer mainly to deal with this. But keep in mind that this is a really important distribution, so might as well get used to it, and we'll see you in the next video.